All right, today we are talking about physical versus chemical changes and evidence of a chemical reaction. So y'all really did physical versus chemical changes yesterday with Marshmallow Man. And that's also something you learned with 6th grade. So let's just put a couple things to remind us about the differences between a physical change and a chemical change. So for physical, there's no new substance. And that's important. Nothing new is formed. So if I tear this piece of paper in half, nothing new is formed. It's still paper. It looks different. If I crinkle it up into a ball, it looks different, but it's still the same thing. I could shred it into itty bitty pieces. I could put it through the shredder. I could turn it into tiny dots, but it's still paper. So physical changes are only changes in shape, size, or state. And y'all do awesome at knowing that a physical change is a change in shape or size. If I tear paper in half, if I crinkle paper, the one that gets y'all is state. So like state of matter. For example, if your ice cream melts, it goes from a solid to a liquid. That is not a chemical reaction. That's not a chemical change. That is just a change of state. If you put ice in a pan on the stove and it melts, it's just a physical change. When you're boiling water to make some pasta or to make some ramen, even if you do it in the microwave, some of that water evaporates. Especially if you're doing it on the stove and you have a lid on the pot and you take it off, you'll see all that evaporation. You'll see it on the lid. That is a change in state. It's going from a liquid to a gas. It is not a chemical change. A chemical change would be a change in physical and chemical properties, which would mean a new substance is formed. So when you are looking at a question that's asking you, is this a physical or chemical change? You're looking, well, is there no new substance or is there a new substance? Those are your big differentiations. So now let's talk about the evidence of a chemical change. So when we're talking about a chemical reaction, there are certain pieces of evidence that we look for. Let's zoom in a bit. And your warm-up video today went over this a bit, and it pointed out something really important. These pieces of evidence that we're going to talk about, they have to be unexpected. And I'll talk a lot about what that means, but they have to be unexpected. Okay, so I stopped and filled in y'all's mnemonic really quick. We remember the evidence of a chemical reaction, the 6 signs, by a mnemonic called City Girls Only Love Their Phones. City girls only love their phones. So let's start with city. The C in city stands for, let's make this look so cool. Let's make this look awesome. Stands for color change. All right, that's enough color changes. Color change. Then I'm going to draw a little example. If we have a beaker plus another beaker, and let's say both of these just have little simple pink liquid in it. And then we combine them and they form a black liquid? That would be unexpected. When you mix a pink liquid with a pink liquid, you think you're going to get a pink liquid. So if you get a black liquid, that's unexpected. That's an example of color change. Putting red Kool-Aid powder into water and it turning red is expected. That does not count. There's nothing new made. That is not a chemical reaction. G stands for gas production. And there's a few ways that you can see a gas production or hear a gas production. It's going to be a bubble or fizz. So if we have something that's trapping the gas, like a bag, like a balloon, like a lid, we'll be able to see the gas form. But if we don't have something to trap it, we might not see the gas. It's released into the air. But we would see bubbles. So I'm going to put some bubbles everywhere. We would hear fizzing. You'd see a lot of bubbles. You'd hear some fizzing. Gas would be your new substance. So in one of our reactions, the bag fills with air. Well, I shouldn't say air. The bag fills with a gas. That is our new substance. You can feel the bag expand. You can hear the fizzing. You can see the bubbling. O stands for odor. And here's my best nose. And it's smelling a nasty scent. Ew. O stands for odor. So if we combine two things that don't have a scent and it starts giving off a scent, that's evidence of a chemical reaction. When things go bad in your refrigerator or your pantry, when things spoil and they change colors and they stink, that's actually a chemical reaction going on. You have a new substance there. You have mold. You have rotting. That is your new substance. So that's the best example of odor I can think of. Like if you leave your milk in the fridge for way too long, it'll get chunks at the top and it'll smell terrible. That's a chemical reaction. L stands for light. So if you mix two things or if you add heat to something and it gives off a bright light, that's evidence of a chemical reaction. We're going to have a few different examples for you of light because that's not one we expect. That's not the most common evidence. T. Ooh, this is an important one that gets messed up a lot. T stands for a temperature change. A temperature change. Now this can be an increase or a decrease in temperature. So I'm going to draw like a little thermometer with like, here's my temperature and it's shooting up or it's going down. This is when something gets hot or cold on its own. That's the key thing. Not when you put it on the stove and you apply heat. Not when you use a candle, a flame of some sort of fire and apply heat. When you mix two chemicals and they get hot or cold on their own. Does not count when we add the heat. We can't put it in the freezer and call it a temperature change. Doesn't count. Last one is one that I'm confident is brand new to y'all. This one is called a precipitate. This is not precipitation. This is not rain and snow. This is when two liquids make a solid. So there are times when you can combine two liquids together and then you get a solid. Sometimes that solid is a powder. Sometimes it's hard to see. And it's just a little powder. Sometimes it's a chunk. Sometimes we do see this happen in test tubes. And it's not that easy to see, but if you wait a while, it'll settle at the bottom. So I'm giving a little example. Sometimes we combine two things in test tubes, and then you wait and you'll see liquid. You'll see the solid form at the bottom as the little particles fall down to the bottom. Sometimes it's more obvious, sometimes it's chunks that float at the top, but this is when we combine two liquids and you get solid pieces. It does not mean that we combine two liquids and they turn completely to a solid. That would be unusual. That would be interesting. This is when we combine two liquids and we get solid pieces. It could be, like I said, powder. It could be small particles. It could eventually turn into large chunks, a whole piece of solid material. So these are your 6 pieces of evidence of a chemical reaction. If it is not one of these things listed, it is not a chemical reaction. Things separating. Oil and water separating, not a chemical reaction. Something floating to the top, not a chemical reaction. It has to be one of these 6 pieces of evidence. They like to try to trick you on the test and say they combined 2 liquids, one floated to the top, or one separated to the top. So that is none of these. It is not a chemical reaction. It has to be an unexpected one of these. So when we put water on the stove and it bubbles, we expect it to bubble. We applied heat. It has to be unexpected.